Okay, in this video I'll explain the concept of for loop with 4 examples. The first example uses this print function. Okay? Print function prints whatever you want in the console window. We can enter all commands in the console window, but instead today we open a new file, a new R script, and write commands in the R file. Okay, so how can I print 1 squared, 2 squared, and 3 squared? I use the print function. I can execute the command one line by line using this, clicking on this run icon. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Now suppose I want to print up to 20 squared. Okay, starting with 1 squared. Suppose I want to print 2 squared, 3 squared, ... up to 20 squared. I can keep on doing this by copy and paste 4 squared, 5 squared, 6 squared. I can do that. But at some point, I feel like not repeating this 20 times. Instead, what I want to do is something like this. All I want to do is print j squared, where j is 1, 2, 3, up to 20. Okay, this is all I want. I can express what I want to do in one line. I don't want to repeat 20 times. This is the idea of a for loop. So I can use for loop for this. The syntax is the following. For and j in 1 to 20, open braces, and in the braces I write the command I want to repeat. I want the for loop to repeat. And this time is printing j squared, where j is in the set of 1 up to 20. This is it. I put the cursor on 4 and I click on run, and voila, R repeats this task 20 times from j equal 1 to j equal 20. That is 1, 4, 9, 16, and so on. Okay, this is the idea of for loop. Now for this first example, we just repeated printing. Okay, printing. But most of the time when we use for loop, we want to calculate something, and we want to save the computed values for later use. So for the second example, let's compute something. Let's compute values, and we are going to save these values for the later use. Okay? For that purpose, we define some vector for the saving purpose. We can make a 0 vector named q. Let's see, q is 0, 0, 0, 0, 0, repeated 30 times. And then, for example, suppose I want to compute 1 squared, 2 squared, and so on. Okay, suppose I want to compute a 1 squared, 2 squared, 3 squared, up to 30 squared, squared 30. Okay, of course we can use a for loop for this, but don't jump to using for loop if you're not used to it yet. Okay, instead just routinely repeat it until you feel until you naturally feel that you don't want to repeat this forever. Okay, you don't want to repeat it 30 times, not forever, but you don't want to even repeat it 30 times. Now, I computed up to, well, from 1 squared to 5 squared, but do I want to repeat this for 30 times? No, because all I want to do is this, right? The ith element of Q is just I squared, and I want to change this, the value of I, from 1 to 30. This is all I want. I can express what I want to do in one line, okay? And I can actually do this using for loop. The syntax is for. We used the J in the previous example, but this is called index variable or dummy variable. So you can use any variable, I or J or K, whatever. So this time we are going to use J. Okay, J in 1 to 30, open braces, and inside is just this. Oh, sorry, I'm going to use I this time. And the ith element of Q is I squared. And I want the for loop to repeat this task 30 times from I equal 1 to I equal 30. Let me first repeat only 7 times, okay? I'm going to change 30 to 7, and this will repeat the task 7 times. Run. Let's see, Q equal 1, 4, 9, 16. Okay, 49 is 7 squared. Okay, so even if it takes very little time, the R is actually repeating it 7 times very fast, very fast. Okay, for example, you can see that. So let's say Q is again, let me run this line. Q is again 30 zeros, okay, and then let's say I want to repeat this task from I equal 10 to 20. Okay, run. So again, it was really quick, but R repeated it for 11 times, okay, changing I from 10 to 20. So let's see, Q is 0, 0, 0, 0, and the 10th element is 10 squared, 20th element is 20 squared, which is 400. Okay, and yeah, this will do. It's very quick, but it is quick, but R is actually repeating, so don't forget that. Now for this task, actually we don't have to even use a for loop, because I can simply say, so let's define a new variable QQ. QQ is just 1 to 30 squared. 1 to 30 squared. And this is enough. Okay, I don't even have to use a for loop. Now, if you don't have to use a for loop, don't use it. We are not practicing a for loop, so it's okay to use a for loop, but in general, for loop takes time. So if you can avoid using a for loop, that's better. Because if you can do this task in 0.01 seconds, okay, without using a for loop, but suppose by using a for loop it takes 0.1 seconds. The difference seems very small, but later you have to write a very, very long code, very big project, okay? And using a for loop or not might cause a very big difference later. Okay, using a for loop might cause 10 minutes of computation time. So if you can avoid using a for loop, don't use it. We are not practicing a for loop now, so it's okay. But next example is actually an example for which you have to use a for loop. You cannot avoid using a for loop. So that's a difference equation. So example 3. So let's compute a difference equation of the following. Okay, the first element is 1. The second element is also 1. And the nth element is let me show you examples. Okay, first example, first term is 1. Second term is also 1. And from the next term on, it is the sum of the previous two. So the third element, third component of this sequence is the sum of the first and second terms. The fourth component of this sequence is the sum of the third and the second term, and so on. Of course, the fifth element is the fourth plus the third. Okay, and so on. In general, the nth term is the sum of the previous two terms. Okay? Now, how can we conduct this task using a for loop? If you are not sure yet, just keep on repeating until you feel that you've got to use a for loop. In the end, you'll see some rule. The rule is this. Okay? By repeating, you'll find the rule, and you can simply express that with a for loop syntax. So for, the dummy variable can be anything. So this time we use n. N is from the third term, okay, from the third term, 3 to, let's say, 20, open braces, and the task to be repeated is the nth component of A is the n minus first component plus n minus second component. Okay? Right, sorry, I should define A. So A is 20 zeros. Okay? So A is just a container, 20 zeros initially, and we are going to compute values using a for loop, and every time we save the result in vector A. So first initial values are 1 and 1. Let me show you. The first two terms are 1, and after that, okay, of course, we can exercise these lines line by line, and we can compute. This is called Fibonacci sequence, and yeah, 1, 1, 2, 3. you can see the rule, right? 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. Okay, it's just the sum of the previous two terms. Now let's conduct the for loop. I did. So now A is this. Okay? Now so far, there was only one line, one task within a for loop. But you can actually, you can have as many tasks as you want inside a for loop. And a for loop repeats the task. Okay? All the tasks. So the final example is going to have two lines inside the for loop. Okay, example 4. And the next is the simultaneous difference equations. Let's say we have K and L and K and L are just 20 zeros initially. And here is the rule. The first term is 1. Okay, let me show you. K and L have 1 in their first components, and after that, the rule is that the nth component of K is the sum of the previous components of K and of L. And the nth component of L is 2 times the n minus first component of K minus n minus first component of L. Okay, this is the rule. This is the rule. And of course, you don't have to jump into a for loop. First, just routinely repeat by copy and pasting. For example, K, the second term of K is the first term of K plus the first term of L, right? And the second term of L is what? 2 times, don't forget this product symbol, 2 times, you cannot do 2k, you have to say 2 times k, the first element of k, minus the first element of L, right? This is the second, how the second term, second components are determined. K and L. How about the third component? The second component of K plus the second component of L. The third component of L is 2 times, don't forget the product symbol, the second component of K minus the second component of L. And while you repeat again and again, in the end, naturally you can see the rule, and naturally you can use a for loop. So as a beginner, don't jump into using a for loop. Okay, first just keep writing it, and eventually you will know the rule. The rule is, well, actually we want to repeat from the second to the 20th components of K and L. It's basically this, right? It's basically this. Of course, we should follow the R syntax. Actually, we can use equal, but let me use the traditional syntax. this left arrow, and we should put product symbol between 2 and k. So this is it. This is it. We want the for loop to repeat these two lines from n equal 2 to n equal 20. Yes, I ran it. Now k is this and l is this. Okay? Be sure that n is from 2 to 20. If you make it like 1, then you'll get error. Do you know why? Because when n is 1, what is n minus 1? 0, right? 0. There is no the zeroth component of k, nor the zeroth component of l. Okay? So it's good idea to actually substitute like this. When n is 2, k2 is k1 plus l1, so it works. When n is 2, l2 is 2 times k1 minus l1, so it works. When n is 20, the 20th element of k is k19 plus l19, so it works. L20 is 2 times k19 minus l19, so it works. So just try substituting this to make sure. Finally, let me explain how to debug inside the for loop. For that purpose, so let me redefine k and l. So again, k and l are back to 0 vectors. Okay, and let me substitute 1 into the first component. So now k and l are this, 0, 0, 0, 0, only the first elements are 1. Suppose I want to execute inside the for loop line by line. Okay, for that, just set up n. Let's say n is 2, right? N is 2, and then put the cursor inside the for loop and run. Because n is 2, R can compute this, the second line as well. You see, the second components of k and l have been computed. And I can say n is 3. And again, I can run line by line inside the for loop. This is how you debug inside the for loop line by line. Okay?